Hello everyone, myself Dr. NCH Ramgopal, working as Associate Professor in Mathematics in the Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. I welcome you all to the today's session on line integral part 2. In the last session, I have introduced what is a line integral, the work done by a force vector and solved two problems also. And today I am going to continue the same, again evaluation of line integral. So we are going to solve two more problems on line integral. So coming to the third problem, using the line integral, calculate the work done by the force F bar along the lines from 0, 0, 0 to 1, 0, 0, then to 1, 1, 0 and then to 1, 1, 1. So here the vector F bar is given and along the lines, so three different lines are given. First line from the first point to second point, I can denote it by O, and this is A, this is B and this is C. So the lines are OA, AB, BC. So we need to evaluate the work done along the lines OA, AB and BC. So here the work done is given by the line integral F bar dot dr bar. But in this particular problem, if I denote the points, the first one is O, second point is 1, 0, 0, A, third point B, 1, 1, 0 and fourth one is 1, 1, 1. Then this line integral is equal to along OA, F bar dot dr bar plus along AB plus along BC, F bar dot dr bar. So we need to evaluate the line integral along each line. So along three lines OA, AB, BC. Now before going to evaluate this, first we need to find F bar dot dr bar. So we have, what is the position vector R bar? Xi bar plus Yj bar plus Zk bar. Then dr bar will be dxi bar plus dyj bar plus dz k bar, and therefore F bar dot dr bar, the dot product between two vectors, is the sum of the products of corresponding elements. So here the x component is 3x square plus 6y, here the x component is dx. So I will write F bar dot dr bar here. This is the first component in F bar, 3x square plus 6y multiplied by the first component in dr bar, dx. So we need to calculate this F bar dot dr bar. So that is the sum of the products of corresponding components minus 14yz dy plus 20xz square dz. So this is F bar dot dr bar. Now we need to integrate this along three lines. So let us start. The first one along OA. Now what are the points here? The origin and A is 1, 0, 0. Now the main thing is here we need to identify, so which values are changing and which are not changing. And it is very clear that the value of Y at O origin is 0 and at A again it is 0. So Y value is 0 at both points. Similarly Z 0, 0. So here we can identify that Y equal to 0 and Z equal to 0. And the change occurs only in X value. So therefore X changes from 0 to 1. So and X changes from 0 to 1. Here X value is 0, 0 to 1. If Y is 0, dy will be 0. Z is 0, dz will be 0. So therefore along OA, F bar dot dr bar is equal to x from 0 to 1. Now what is F bar dot dr bar? Let us go to the previous slide. So this is F bar dot dr bar. And in the present problem, since y is 0, z is 0, dy is 0, dz is 0. So this term becomes 0 and the last one also 0. So last two terms vanishes. And y is 0, so this becomes 0. And only 3x square dx will remain. So which is 3 into x cube by 3 from 0 to 1. The integral of x power n is x power n plus 1 by n plus 1. So x cube by 3. And by applying the limits, so here the answer is 1. Similarly, we can evaluate the line integral along AB also. Along AB, what are the points? 1, 0, 0 and B is 1, 1, 0. Now again identify the values which are changing and which are not changing. And here it is very clear that here x is 1 and at B also the value of x is 1. So the value, we can fix this value x equal to 1 and z is 0 at both points. So and z equal to 0. So dx will be 0 since x is a constant and dz is also 0 and y changes from, here we can identify that the value of y is changing from 0 to 1. Y changes from 0 to 1. So therefore, the line integral along AB f bar dot dr bar will be y from 0 to 1 f bar dot dr bar. So this is f bar dot dr bar and here dx is 0, dz is 0. So the first term vanishes, last term vanishes and x equal to 1 but y equal to 0, here we have that y. Z equal to 0, here z equal to 0. So therefore this also vanishes. So 0 which is equal to 0. Similarly, let us calculate the line integral along BC. And what are the points? B is 1, 1, 0, 2, C is 1, 1, 1. And again here it is very clear that only z changes from 0 to 1, whereas x and y are fixed values, x equal to 1, y equal to 1. So that implies dx will be 0, dy will be 0, the derivatives vanishes and z changes from 0 to 1. So therefore, the line integral along BC f bar dot dr bar is equal to evaluation of integral from z equal to 0 to 1 f bar dot dr bar dx 0 dy 0 dx 0 dy 0. So first two terms vanishes and x equal to 1 y equal to 1. So here x equal to 1. So 20 z square dz, 20 z square dz. So 20 is a constant and z square derivative is z cube by 3 from 0 to 1. So which gives 1 by 3. The upper limit is 1, lower limit is 0. So 20 by 3. So here the line integral is evaluated along three lines OA, AB and BC. Hence, the line integral f bar dot dr bar, which is the work done along the curve C, is equal to along OA f bar dot dr bar plus along AB f bar dot dr bar plus along BC f bar dot dr bar. And the first value we obtained is 1, second is 0 and the third one is just now we calculated 20 by 3. So overall the answer or the work done is 23 by 3. Similarly, let us solve one more problem on line integral. Find the circulation of f bar along the circle in the xy plane. So here the given curve is a circle. We know that circle is a closed curve. That's why it is required to calculate the circulation. So here we represent that as, so circulation means the line integral along a closed curve. So we use this circle here, f bar dot dr bar. So the same thing, we know that dr bar is dxi bar, dyj bar, dzk bar. Since r bar is xi bar plus yj bar plus zk bar. but in xy plane z is 0. So therefore dr bar will be dxi bar plus dy j bar. And now f bar dot dr bar, we need to calculate f bar dot dr bar. So the dot product between these two. So here in the first one, the first product is 2x into dx plus second x plus y minus z, second component into second component dy, because I dot I is 1, j dot j is 1, and all other the dot product between different unit vectors is 0. So obviously for the third one we get 0. But in the xy plane z is 0 in xy plane. So therefore f bar dot dr bar will be 2x minus y dx plus x plus y dy. Now we need to integrate this along the given curve. Now what is the given curve? Given curve is a circle, x square plus y square is equal to 4. So it's a circle with center at origin and radius equal to 2. Now we need to find limits. Here we are evaluating the line integral, that means single integration. So with respect to one variable only we can integrate. So we have to transform either y to x or else x to y, or both in terms of another variable. Since it is a circle, we can use with radius 2. It's a circle with center at origin and radius equal to 2. So we use a substitution, put x equal to 2 cos theta, y equal to 2 sin theta. So therefore dx equal to minus 2 sin theta d theta and dy equal to 2 cos theta d theta. And therefore the line integral or circulation is f bar dot dr bar, where what is that f bar dot dr bar? 2x minus y dx, 2x minus y dx plus x plus y dy, x plus y dy from, so the limits here, since we are using this substitution and it's a circle, we know that the theta value changes from 0 to 2 pi. So this is theta from 0 to 2 pi, 2 into x, so 4 cos theta minus 2 sin theta, dx is minus 2 sin theta d theta plus x plus y, 2 cos theta plus 2 sin theta into dy, 2 cos theta d theta. So first we need to simplify this. So that is equal to theta from 0 to 2 pi. So first minus 8 cos theta sin theta plus 4 sin square theta, and here 2 into 2 plus 4 cos square theta and 2 into 2 4 sin theta cos theta d theta common. So that is equal to theta from 0 to 2 pi. So 4 sin square theta plus 4 cos square theta, this value 4 sin square theta plus 4 cos square theta, we know that sin square theta plus cos square theta equal to 1, therefore we get 4 here, and minus 8 cos theta sin theta plus 4 sin theta. So this is 4 into 1 minus 4 cos theta sin theta d theta. So overall 4 constant, theta from 0 to 2 pi, this is 1 minus sin theta cos theta d theta. So we need to split this. We need to split this into two parts. 4 into integral d theta 0 to 2 pi minus, let us multiply and divide with 2. Then 2 sin theta cos theta becomes sin 2 theta where theta from 0 to 2 pi. So 4 into, this is theta from 0 to 2 pi minus half into integral of sine theta is minus cos theta. So here we get minus cos 2 theta divided by 2, 0 to 2 pi. So here the upper limit is 2 pi, lower limit 0, and minus into minus plus 1 by 4 into first upper limit cos 4 pi minus lower limit cos 0. So this is 4 into 2 pi plus 1 by 4 into cos 4 pi, which 4 is even. So we get 1 minus cos 0 is 1. So finally the answer is 8 pi. So here sin 2 theta is 2 sin theta cos theta. We have used this formula here. And also cos n pi is minus 1 power n. This sign depends on n. If n is even, we get plus 1. N is odd, we get minus 1. So plus or minus 1. And like this we find the line integral of the given vector. So today we have solved some problems on line integral. So the work done and the circulation are evaluated for the given vector. In the next session, I would like to introduce surface integral. So this is for today's session. Thank you.